Welcome to your Algebra 2 lesson 4.7. This is video number 1, and today we're going to learn how to complete this square. Ultimately, our objective is that you will be able to solve quadratic equations by completing this square. So what we want to do is start off with an example where you can solve a quadratic equation by finding square roots when you actually have a linear term for x. Now that only works, or it works only rather, when you have a perfect square trinomial. In other words, remember, look at this. Look at x squared minus 8x plus 16. That's a perfect square trinomial. 16 is equal to 4 squared. Negative 8 is negative 2 times 4, and then you've got the x for the base of the x squared. So it's a perfect square trinomial and can be factored as x minus 4 quantity squared equals 25. So when you can write a trinomial in that form, you can actually go ahead and solve the quadratic by taking the square root of both sides, just like we did in the last a couple of classes ago with quadratics that didn't have a linear term. Because what we would do at this point is just take the square root of both sides, remembering on this side with the plain number, the 25, to do plus or minus. So we would end up with x minus 4 equals plus or minus the square root of 25, which is 5. And then we would add 4 to both sides, and that would solve for x. So x is going to equal 4 plus or minus 5. Now, on this particular case, we would want to go ahead and split up the two cases and simplify, because we can simplify. So 4 plus 5 is 9, and 4 minus 5 is negative 1, and those are your two solutions to your quadratic equation, 9 and negative 1. In example 1, the trinomial x squared minus 8x plus 16 is a perfect square because it equals x minus 4 quantity squared. Sometimes you need to add a term to an expression x squared plus bx to make it a square. The process is called completing the square, and if we complete the square, we can actually solve any quadratic by taking the square root of both sides. To complete the square for the expression x squared plus bx, you're going to add b over 2 squared. So x squared plus b over 2 squared equals x plus b over 2 times x plus b over 2, which is x plus b over 2 squared. Okay, we're going to find the value of c that makes x squared plus 16x plus c a perfect square trinomial. Then we're going to write the expression as the square of a binomial. Okay, so for step 1, we're going to find half of the coefficient of x, because the coefficient of x is our b. So 16 over 2 is 8. For step 2, we're going to square the result from step 1. So 8 squared is 64. For step 3, we're going to replace c with the result of step 2. And so we get x squared plus 16x plus 64. And here is a little picture of a completed square there. The trinomial x squared plus 16x plus c is a perfect square trinomial when c equals 64. Then x squared plus 16x plus 64 equals x plus 8 times x plus 8, which is x plus 8 squared. So we've written the trinomial with the value that makes it a perfect square, and then we've written it as a binomial squared, x plus 8 quantity squared. Solving equations. The method of completing the square can be used to solve any quadratic equation. When you complete a square as part of solving an equation, you must add the same number to both sides of the equation in order to keep balance, to keep the statement of equality true. So we are going to solve x squared minus 12x plus 4 equals 0 by completing the square. So we're going to write the original equation. So we've got x squared minus 12x plus 4 equals 0. And then we're going to write the left side in the form x squared plus bx. That means we need to subtract the 4 over to the other side. So we're going to have x squared minus 12x equals negative 4. Okay, we need to do our b over 2 squared. And guys, I strongly recommend that you write this out. So we want to add b over 2, so negative 12 over 2 squared. Negative 12 over 2 is negative 6. Negative 6 squared is 36. We want to add 36 to both sides. So on the left-hand side, we've got x squared minus 12x plus 36 equals negative 4 plus 36. Now we want to write the left side as a binomial squared. If you will keep track of what b over 2 was, what this is right here, what we squared to get the 36, that is going to tell you how to factor immediately. It's always going to be x, and then if this is negative, it's going to be minus the value. If it's positive, it's going to be plus the value. So I can look at this immediately and go, oh, okay, that's x minus 6 quantity squared. Or you can think through and go, okay, x squared minus 12x plus 36, so 36 is 6 squared. Half of that is 36, and then so the square root of that is 6 times 2 is 12. So let's see if there's a negative there. We need to do minus 6, or you can just go, it's always going to be x, and then whatever's inside this little parentheses right here. If it's positive, it'll be x plus that value. If it's negative, it's x minus that value. But we've got x minus 6 squared equals 32. Now we're going to take the square root of both sides, remembering to do plus or minus on the plain number side. And so we get x minus 6 equals plus or minus square root of 32. Let's go ahead and solve for the x by adding 6 to both sides. And so we get x equals 6 plus or minus square root of 32. Now we need to look at that square root of 32 and see if we can simplify that. 32 does have a perfect square factor of 16. So square root of 32 equals square root of 16 times 2. Square root of 16 is 4, so it equals 4 times square root of 2. So we're going to have x equals 6 plus or minus 4 square root of 2. So we have two solutions, 6 plus 4 square root of 2 and 6 minus 4 square root of 2. Now if you just want to write your final answer as 6 plus or minus 4 square root of 2, that's fine by me. Okay, or you can write it out as the two separate solutions. Let's look at one more example and then we'll move on to video 2. We're going to look at how to solve ax squared plus bx plus c equals 0 when a does not equal 1. So far, a has been 1, but what happens? What we're going to do is we're going to write the original equation, and then we're going to divide each side by a. So whatever that coefficient is in front of the x squared, we're just going to divide both sides of the equation by that value. Then we're going to write the left side in the form, little typo there, it should be form x squared plus bx, and then we're going to solve by completing the square. Okay, so we're going to solve 2x squared plus 8x plus 14 equals 0 by completing the square. So we write the original equation, and then we divide each side by the coefficient of x squared. Well, x squared has a coefficient of 2, so we're going to divide everything by 2. So on the left, that gives us x squared plus 4x plus 7, and then on the right, 0 divided by 2 is just 0. And then we work from here. So we're going to write the left side in the form x squared plus bx, so we're going to subtract this 7 over. So we have x squared plus 4x equals negative 7. Now we're going to actually complete the square by figuring out b over 2 squared. Well, b is 4, so we have 4 over 2 squared. 4 over 2 is 2. 2 squared is 4. So we add 4 to each side. So we have x squared plus 4x plus 4 equals negative 7 plus 4. We want to write the left side as a binomial squared, so it's going to be x, and then since this is positive 2, inside the parentheses right here, we're going to have x plus 2, the whole thing squared. See, there we go. Equals negative 7 plus 4 is negative 3. We're ready to take the square root of both sides. And so we have x plus 2 equals plus or minus square root of negative 3, because we'll always do plus or minus on the plain number side. We're going to solve for x by subtracting 2. So we get x equals negative 2 plus or minus the square root of negative 3. And we want to simplify our square root. Now, previously we probably would have put, oh, well, this isn't defined for real numbers. It's not defined. But we learned about the imaginary unit, so we're going to put our I out. And so we're going to have x equals negative 2 plus or minus I square root of 3. So you have your two solutions, negative 2 plus I square root of 3 and negative 2 minus I square root of 3. And you're welcome to write them out like that, or if you just want to write them as negative 2 plus or minus I square root of 3, that works as well. Okay guys, that's it for video number 1. I'll see you in a minute with video number 2.